what you're looking for are the transformations. So like in the first one here, this is right 4 because of this x minus 4. Minus 3 is down 3. It's not flipped, like there's a 1 in front, so it opens up.
So in this
So
case, it should be B because it's going to the right 4.
Yep, so this is graph B. Number 2 is also right 4. This time it's up 3, but it opens down because there's a negative 1 there.
All right.
So that looks like graph A.
And number 3 should be, what is it?
Left 4, down 3.
Should be D for number 3.
Yep. And then this one is left 4, up 3, and then it opens down because of that negative 1. So by process of elimination, it is C.
Awesome. Let's go on to number 5.
Is number 5 say x squared minus 2x minus 15?
Yes.
Okay. There's quite a few things that it asks you to do here. We have definitely done this before, and I have no problem doing it again. I'm just letting you know that again. This will be the last time I do that. So the function, you have to write it in this completing the square form. That's what part A is saying. There's a couple of ways to do that. You can literally complete the square, which it might ask you to do on a test. It might not. The second option is to find the vertex or determine it. That's what we're going to do. We're going to do option 2 here. So the vertex is minus b over 2a. And in this case, a is 1, b is minus 2, and c is minus 15. Would you calculate x for me, the x coordinate of the vertex?
For the vertex, it should be just 2. Oh, wait, so no, just 1.
Minus 2 over 2 times 1. Minus or positive 2 over 2, which is 1. So that's the x coordinate. That's h. We're trying to find a h comma k. To find the y coordinate, you need to put that 1 back into the original equation. 1 squared minus 2 times 1 minus 15. So when you do that, you get 1 minus 2 minus 15. You end up getting minus 16. So that's your vertex. Your vertex is 1 comma minus 16. That allows you to write it in the form a x minus h squared plus k. So it's x minus 1 because that's what h is. K is minus 16. Great. A is the same as up here. So in this case, a equals 1. It's the same as this one we just found up above.
Okay.
That's your p of x. We've actually already done part B, which is to give the vertex the parabola. There's part B. And then to graph it, we're going to use just transformations again. This one is right 1, down 16, still opens up. So you can right when so it's it's down here and it looks something like that. It's a very rough sketch. Okay, should we move on to 7? Or is that enough?
Could we? I think that I can do this subject by itself. Can we go to lesson 3.5, please?
Okay. Yep, I'm there. What are we doing next?
Perfect. Let me take a look at what the problems are. And we will start at, where is it? Number 1 through 8.
Number 1 through 8. So it's looking at this graph and it wants all these sort of information from it. Okay, let me get that here. That's not what I wanted. That is what I wanted. This is the correct, this is what you want? Okay.
Perfect.
Use the extrema to determine the minimum degree of f. These are really nice conceptual questions. They're actually really good to answer after you're all done, because you can answer them really quickly. Because it's here and here, like it goes down and down. Okay, that tells you that it's even. But that's not what it's asking for. It's asking for the degree. So this is called a turning point. This is called a turning point. And this is called a turning point. A turning point is when it switches from going like up and to the right, down to the right, or down to the right to up and to the right.
I think I remember these.
So there are three turning points, the three TPs, if you will. The degree, the minimum degree, is equal to the turning points plus 1. So since there are three turning points, the minimum degree is 4.
All right. And number 2, use the extrema to determine the minimum degree of G.
So same thing, 1, 2, 3, 4 TPs, 4 turning points. So you add 1 to it to get the degree, which is 5.
Oh, okay.
You have to remember that relationship.
Wait, can you say it one more time?
The minimum degree is the number of turning points plus 1.
Plus 1, okay.
You have to remember that. Sometimes they give you the degree and ask you the number of turning points. So you got to be able to go forwards and backwards.
Okay.
Number 3, give all local extreme points of f. Okay, so tell whether each point is a maximum or a minimum. So they're looking at this is one of the things that I don't particularly like about this. Let me I think we can still do it on this picture. So AB is a max.
Yeah.
Why is that a max? Well, it's bigger than the places around it. Like if you were to walk up a hill and get to A comma B, you'd feel like you're at a maximum. And if you went down the hill and you got to E comma T, what would you say there?
So A comma B would be a max. For E comma T, that would be a minimum.
Minimum. Yep. And then you go back to C comma D, and this is what's maybe unclear, is you can actually have more than one min and max.
Oh, okay. So we have 2 maxes and 1 minimum, right?
Yes.
Oh, and we just name them. Okay, I see what you mean.
Now 4 is looking at G. There's often this confusion of like, well, can there only be one max or can there only be one min? The answer is that there can be more than one max or min. So like N comma P, this point up here, well, that's a max. R comma H, that's a min, okay, because you went down. When you go up to JK, J comma K, it's bigger than the other places, so it's a maximum. It's maximum because it's bigger than the places around it. And sometimes that's unclear, but it's like relative to your surroundings, what is it? Well, J comma K is a max. L comma M is a min because it's lower than its surroundings.
All right.
So it doesn't matter, you know, if you ever gone on a hike.
So J is a max. So J comma K is a max.
Yeah.
In that case.
Yeah, like if you ever gone on a hike, like you might feel like you've gotten high up, and then you look behind, you look near you, and you're like, oh, there's actually a taller mountain to climb, kind of thing. So you're still at a max. You're just not at the super max, so to speak. Is that clear?
Yes, it is. All right.
Okay, so the 5 and 6, these are a little bit. These are more complicated to explain. So the absolute extreme points does it have these are really what I refer to as global maxes and global mins. So for example, A and B and CD, those are global maxes. There's nothing bigger than A, B, or CD because the graph goes down, goes down, goes down, goes down. So A comma B, C comma D, those are global maxes.
Oh, I see.
Okay. Now the problem is this does not have a global min because these go down forever. This blue graph goes down forever.
Oh, so you can't determine that.
So,
Right.
so there's none, basically, is what they would say. The graph on the right is kind of worse because it actually goes up forever and it goes down forever.
So is there no global min or no global max?
That's exactly right.
All right. We're doing number 7. Give the local and absolute extremes of f. Oh wait, no, did I skip number 6? Oh no. All
right. There's none for number 6.
What? All right.
So give the local and absolute extreme values of f. We've kind of already done that. So E comma T is a local min.
Mm-hmm.
A comma B, C comma D, those are local maxes. But they are also, and this is where it gets confusing, they're also global maxes. We're going to have to kind of leave it at that. And when you take calculus, we can get more into it. So the on the other side here, N comma P, that's a local max because it's higher than everywhere else. But it's not the biggest max because the graph goes up forever. R comma H is a local min, but it's not the biggest minimum, or it's not the smallest minimum because there's values down here that are smaller. J comma K is a local max because it's a little bit higher than everywhere else, but it's not the global max because the graph actually goes up forever. And then L comma M is a local max because I'm sorry, local min, sorry, I misspoke on that, because it's smaller than everywhere else, but it's not the most small value because the graph goes on forever.
All right, that makes sense.
I hope we get to do 9 through whatever, because that's kind of more likely to be your test questions.
Mm-hmm. All right, let's start up on number 9.
For 9 to 13, there's 4 graphs that I have to tell you about in advance so that you know how to decide, because there's only 4 possibilities. And it's based on 2 things. It's based on whether the degree is even. So we're going to look at even graphs first. So an even graph either starts high and ends high, or it starts low and ends low. Like think of a parabola, U shape.
Yeah.
Okay, or like this. Now, what affects whether it goes up or down? Well, it's the A value. This is the A value is greater than 0. This is the A value less than 0. So when I say A value, do you know what I mean by that?
Is it like the number in front of like the x minus h squared plus k?
Yeah, it's actually the highest degree power. Whatever number's in front of the highest degree power. And we're gonna do all these, but there's 2 more graphs that you need. So there's the odd degree. And it has 2 options. It either starts low and ends high, starts high and ends low. Mm-hmm. And this one is if A is greater than 0. This is if A is less than 0.
So there you go.
Okay, so there's 4 graphs that you have to know. And I can't get them all on one screen, but we'll refer back to them. So let's look at 9. When I look at 9, and I'll just snip it in here. There's 2 things you have to figure out. You have to figure out what is the degree. Okay, what is the degree? And the degree in this case is 3. That's the degree. Is it odd or even?
That is odd in that
Odd.
case.
And then you look at the number in front here. Is this positive or negative?
It's positive.
It's positive. So this means that A is greater than 0 and it's odd. So we go back to our chart here. Well, these two are for even. This one's for odd. This one on the left here is for what we have here. So this one looks like this. So that's what those pictures are supposed to like indicate in the prompt where it says use an end behavior diagram to describe the end behavior.
Okay.
So your instructor is looking for these arrows here.
Yeah.
Okay. Are we doing 11 next?
Yes.
I think I heard a yes. So in 11, again, two things you have to do. You have to find the degree. The degree is 5. That's odd. This in front is negative. That means A is less than 0. So you go back to your chart. You're like, I got two odd ones, so it's one or the other, but this time it's the one on the right because A is less than 0. So this one here, the graph of it, starts here, ends here. We don't know what it does in between. We don't care. We just care about the end behavior.
Just the arrows, basically.
Just the arrows. I mean, it could be multiple choice because there's only 4 options. There's only so many possibilities here. So let's look at 13 next. So what is the degree of this?
The degree is 4, right?
It's 4, and is A
and
positive?
And it's more than 0.
A is positive. Okay, so this case, I know you can't do that, but it'll scroll up like I can, but it looks like this. Now I put the graph in the Cartesian coordinates. I think that's more useful than just putting arrows up. And they put little curves in there, whatever. That's not. It's important that you know what direction it goes.
Mm-hmm. Alrighty.
Okay, are we up to 15 now?
Yes.
All right. So the thing that this is kind of an exam type question. The degree is actually here. It's not the one in front. It's the highest degree.
Oh, okay. So it would be a negative though. So it would be less than 0.
Degree of 6, which means even A is less than 0 because of this. And that means it starts low and ends low.
Okay. Goes slow and ends slow.
But I like 17. It's the same thing. It's the same thing. You're looking at really is the degree even or odd? Is the leading term positive or negative?
Mm-hmm.
What does this one do?
X to 10,000th power. Does it still do a parabola?
It's all of these are exactly the same. You need to figure out the degree. Is it even or odd? And then is the leading term positive or negative?
Oh, so the degree is even, and it's a more than 0.
There's a 1 in front, so it's like this: circle, circle, and those two tell you that it goes with this one.
Oh, okay, I see what you mean. Can we move to number 33?
Yes. (33 through 36).
Yes.
Okay.
Actually, we'll be doing it by odd.
We'll do them all. I mean, they're all the same here. So this is the same type of question. You have to look at each of these, 33, for example, and what's the degree? 3, and what's the leading term? Is it positive or negative?
Positive.
Positive. So that means if I draw a little graph here, it's that and that. So which of these graphs starts low and ends high?
Only D in this case.
So it must be D. Let's look at 35. It's even and it's negative. So that means it's low and low. So it must be graph B.
All right. Now, I'm going to go to number 37.
Yep. Let me just snip these in. Same. I'm going to have you do 37. I'll talk you through it, but what I want you to tell me is what is the degree of this polynomial, and is A positive or negative?
Degree is 3, and A is positive. So goes down, ends up, and it would be A.
It would be A. Yeah. I know we don't need to do 38, but could you just do that for me? It'll make me feel better about your understanding of this.
So which graph is this one? Well, degree is 4, which is greater than 0. And then it's positive for X. So down, up again. Would it be A again?
Well, this is an even power. It's even. That means it either starts high, ends high, or starts low, ends low. There's a 1 in front, so it must be this positive one.
Oh, okay. So then it would be B.
Looks like it would be B. All right. How many real zeros does the graph in C have? How many real zeros? This is another way of asking, how many times does it touch or cross the x-axis?
The x-axis is just a once.
Once. So the answer is 1. Let's say instead 39 it referred to graph A. How many times does graph A? How many real zeros does graph A have?
3.
3. Where it gets a little dicey is B. B touches. Those are counted twice. So there's 2 there at B. It crosses, that's 3. Comes back up, hits again, that's 4.
All right. And for 41, which of these graphs cannot be that of a cubic polynomial function? So x to the third.
Yep.
Which one can't be that one?
If you're not sure how to answer this, think about what an x to the third would look like. It's odd. This number in front could be positive or negative.
If it were positive or negative, it would go up and up and down, right?
Nope. Down and up for the positive, and then this and this for the negative. This chart,
then it would be B.
This chart up here, you gotta have, like, I don't know if you didn't get it down in your notes, like you have to know this really well, like as well as rolling out of bed and what's your address kind of thing. Phone number. That's why if we go back to the graph, the ones that cannot be that of a cubic, well, let's talk about the ones that could be. It could be A and it could be C because they both have this behavior over here on the right. B starts high and ends high. Oh, well, it could be D too because D.
Yeah, it's because D goes up and then goes down.
The problem with D is that it has too many zeros.
Okay.
So it's kind of a exception to the rule. Yeah, because it really, you're thinking like, well, I mean, he just said if it starts, if it goes opposite directions, it could be a cubic. Well, there's other things too. It's not just as simple as that. You have to look at how many zeros it has. A cubic has 3 zeros. So that's why A could be the answer. And you might think, well, C only has 1 0, so how could it be the answer? Well, it has potentially 2 imaginary zeros that you can't see. But D crosses once, it touches, that's 2 more, that's 3. Hits again, that's 4. Hits again, crosses again, that's 5. So D is a minimum of a 5th degree polynomial. That's why D is not possible, but A and C are.
Okay. So it can't be B or D in this case.
Yes, that's correct.
Okay. Okay. All right. Can we move on to number 43?
How many negative real zeros does the function graphed in A have? So negative means left of the x-axis.
Mm-hmm.
So it looks like it's just here. There's just that one that's at this value. It has 2 positive real zeros, those over here, but it's only asking about negative real zeros. There's not, I mean, I can write down some of these things, but they're much more verbal. It's almost like every graph we could ask the same questions of. Like you should think to yourself, well, how many negative real zeros are there in graph B, for example? Well, there's 2 because it touches there. It touches here at B twice. I mean, that kind of thing. Because really, your instructor could ask this about any of them.
That makes sense. All right, for number 45, which one of the graphs is that of a function whose range is not negative infinity to infinity?
So whenever it's a not question, I always try to focus on, I ignore the word not and say, okay, which ones have a range that is minus infinity to infinity? And like, for example, graph A does, because it goes down forever and it goes up forever.
Mm-hmm.
Graph C goes up forever and down forever. Graph D goes up forever and down forever. So if the word not wasn't there, the answers would be A, C, and B. Do you agree with that?
Yeah.
And so when you throw the not in, the not means, well, not those. So it must be B. Well, let's look at why. Does B have a minimum? Yeah, right there.
Mm-hmm.
That's the minimum. And it goes up forever. So its range, the range of 45, the range would be minus 100 to infinity. And that would be another way to do this, is to identify the range of each one and then figure out which one matched up.
All right. Next, can we move on to lesson 3.7?
3.7. I see 3.6. There, 3.7.
I think I sent it at the end, or did I not? Because I can resend it to you if you want.
Not seeing it. This is on my second run through. I'm seeing 3.6, not 3.7.
My bad. I have to send you 3.6 instead of 3.7. Let me take pictures of those right now. All right, I'm setting it right now. It should come in just like a few seconds.
All right, there it is. Okay, I've got it up here. Which question on 3.7 to start with?
Number 1, please.
Number 1, okay. Do not use a calculator. Be like someone telling me not to drive my car to Walmart. It's like you're not going to walk. Okay, so these complex roots here, 2 plus I, they always come in pairs. Okay, so it's not 4 comma 2 plus I. What it really is, it's 4 2 plus I comma 2 minus I.
Mm-hmm.
Okay, and you always write your polynomial. Your polynomial is always written this way. It's a x minus factor times x minus factor, and so on. So in this case, it tells you that the leading coefficient is 1. That means that a is 1. Okay, so we don't have to worry about that. So in your case, your p of x is going to be x minus 4 times x minus 2 plus I. Notice that's in parentheses.
Mm-hmm.
X minus 2 minus I. And again, notice that's in parentheses. You want to deal with this first. Okay, and to do that, you're gonna distribute the negative, first.
It should like come out to be like x squared minus 4x plus 5, right?
I haven't done it, but it becomes something that you can't factor. Did you say x squared minus 4x plus 5?
4x plus 5, yes.
Yes, and then you get this x minus 4, and you have to multiply that out.
At the end, I ended up getting x cubed minus x squared plus 21x minus 20.
That sounds super reasonable. What I'm going to do right now is new share Wolfram Alpha. I think we did this over the summer. If you just type in x minus 4, x minus 2 plus I, x minus 2 minus I, and you just hit enter because you don't know any better, and you let this computational engine go, it's going to eventually produce the correct answer here. This x cubed minus 8x squared plus 21x minus 20. Is that what you said you got?
Mm-hmm.
Okay. I like this tool to compare your answer to what it's supposed to be. That way you know what your target is.
Mm-hmm. I think I got correct.
I would definitely suggest using it for your homework just to make sure it's a lot of work here, but if you make a tiny sign error, you run into problems. So do we have to do number 3?
Yes, and after that, we're done with these types, and we go to number 13.
Okay, so 3 seems less sophisticated. I'm not sure why they did that. The I has to be paired with something. It's really like I plus 0, so it's paired with I minus 0, or just in this case, actually, I wrote that completely wrong. It's 0 plus I, so it's paired with 0 minus I. So it's 5 comma I comma minus I.
Oh, okay.
So you write your factors as x minus 5, x minus I, x minus minus I, which becomes x plus I. But the key here is to see that's x minus I, x plus I. You always deal with this first. If you do this correctly, the I should get x squared plus 1.
So x squared plus 1, and then we multiply that by x minus 5. And that should be something like x cubed, what is it? Minus 4x squared, and then minus 5. Is that correct?
Yes, you should get x cubed minus 5x squared.
Oh wait, I got minus 4x squared. Did I do that? Oh, I did that incorrectly.
minus 5. Well, you're multiplying by x minus 5 here. So you're going to get the x cubed. You get the minus 5x squared. You get the plus x, the outer, and the. I'm just doing the little foil thing.
Oh, never mind. You were foiling it. Okay. All right.
So
Can we go
down
on
to
to number
13?
13? Yes.
All right. For each polynomial, find all remaining zeros. The nice thing is they give you one. Whenever you get one and it's a cubic, you can immediately reduce it to a quadratic. And the thing is, you can always solve a quadratic, always.
Yeah.
So, like it's super good here. I would use synthetic division. 1, -1, -4, -6. Bring that one down. Okay.
1, 3.
We expect to get a 0 there because of that.
Yeah, of course.
If you don't, you made a mistake. So this becomes x squared plus 2x plus 2.
Yeah.
And this is x minus 3 out here.
Do we multiply it by that? Is that what's happening?
No, if you multiply by that, it's like making 4 right turns. You get back to the original. Okay.
Oh, okay.
I'm just writing it in factored form. We're solving though. So you would try to factor this. You'd realize that doesn't factor. So that means you got to use quadratic formula. Yep.
All right. So it'd be like -2 plus or minus square root of 2 squared, which is 4, minus 4 times 1 times 2. So that turns into 4 minus 8. And then this is all divided by 2 times 1. So it'll just be 2 on the bottom. Should be turn out to -2 plus or minus square root of, what is that, -4 over 2?
Yep.
And do we do the pull out the I and make it 2?
Yep.
All right. -2 plus or minus 2I over 2. So then it just turns to -1 plus or minus I.
Good. Your zeros are 3, comma, -1 plus I, -1 minus I. And it's important that you actually write out the zeros this way. Otherwise, you don't get credit for it.
-1 plus I and then -1 minus I. Yeah, because they want to see all the work and stuff.
Yes. What are we doing next?
Number 15.
All right. So what I want you to do is do your synthetic division for that.
Does it matter if I do just 3 or -3?
You're going to do them both.
First, do them both?
You do them both, okay. And then the reduced one, you do the other number.
Oh, so once I get that, okay. All right. 1, 2, -10, -18. All right. So we got 1, -3, -1, 3, -7. We got 21. Wait, what? Oh, I did that wrong. Oh no, there's a 9 over there. I missed that. We got 3. All right, -9. Then we get 0. This should be like, what is this? X cubed minus x squared minus 7.
Yep, but you actually just want to put that 3 in the box.
Okay.
And just start again.
Yeah, it doesn't really matter if you.
Yeah, it's the mistake to think, oh, I've got to rewrite this here again.
And that's 1. 1 times 3 is 3. And it's just +2. 6. 1. -3. We got 0. So the factored out form should be x squared plus 2x minus 1.
And then you got an x minus 3 and an x plus 3 to go with it from these.
Oh yeah, from factoring out the zeros.
Yeah. Yep.
Plus 3 minus 3. All right.
So now this right here doesn't factor. You shouldn't be surprised. You're gonna have to use quadratic formula on it.
All right. So -2 plus or minus square root of what is it? 2 squared, which is 4. 4 minus 4 times AC, which is 1 times -1. Oh, that's what's kind of nice. It turns into square root of 12. Wait, no, that's not very nice.
Should be square root of 8 on that.
Oh wait, never mind. Yeah, 4 plus 4 is 8. 8. I'm not gonna factor that out into 2 root 2.
Yep.
Over 2. So all the zeros should be something like that. So that turns into like -1 plus or minus root 2. Is that how that works?
That's right. And then you just separate them apart and get your
Negative. All right.
get your factors.
All right. So we got zeros. The zeros are -3 plus 3 minus 1 plus root 2 and -1 minus root 2. There we go. And now we go on to number 19.
You said 19?
Yes, sir.
Okay.
19.
It says find a polynomial of least possible degree having real coefficients with the given zeros. Let the leading coefficient be 1. Okay. I'm sort of shocked you have to do 19. I mean, 19 is
Easy.
well, it's not really related to anything you're doing in the sections. It's very much a warm-up one, but you just write x minus the factor or the 0. So in this case, it's x minus 5, x minus a minus 4. It's always x minus the 0. I may have wrote that improperly up above. So in this case, it's x minus 5 times x plus 4, and you have to FOIL that. X squared minus x minus 20. They tell you that a is 1. Normally there's an a in front, but it's equal to 1 this time.
All right. And do I do anything with this at the end?
That's it.
That's it? All right.
This is your answer.
Next is 22.
Okay, so 22 is better. The thing that they're not telling you, they're kind of giving away here, is that it's not just complex numbers that come in conjugate pairs. These square roots also come in conjugate pairs. So what I mean by that is like another way that they can present 22 is they can say, oh, the factor is 3 and 1 plus square root 2, and you're supposed to know that this corresponds to 1 minus square root 2 also. You still write your polynomial of x is still x minus a 0, x minus your 0, and so on.
All right.
So in this case, it's x minus 1 plus square root 2, x minus 1 minus square root 2, x minus 3. So it's just like the i's, the complex numbers. It's 1 plus, 1 minus. This is what you want to work on first. If you do this part correctly, the square roots will go away. Just like if you do the i's correctly, when you FOIL it, it goes away. So you can definitely multiply this out here. You get x squared minus x plus x root 2, and then you get minus x plus 1 minus square root 2, and then you get minus x squared 2 plus square root 2 minus square root of 4. So you end up getting x squared minus 2x. This is minus square root 4 becomes minus 2 plus 1 is minus 1. And then from here you can multiply this out if you need to. These are quite lengthy. They're easy to make errors. It used to be on your midterm or final exam in this class that they had all the possible variations on it, so you had to be really careful with signs, things like that. So this is x cubed minus 2x squared minus x minus 3x squared plus 6x plus 3. So you end up getting x cubed minus 5x squared plus 5x plus 3. And you exhale. Coming up on the end of the lesson here. Anything else I could just answer briefly?
31, please.
Yeah. You have Desmos for this if you need it. They're giving you the factored form, which is really useful because there's so many things. It just depends on like how it says rough sketch. You can actually do quite a bit more here than just a rough sketch, but we'll use that term here. The factored form here gives you the zeros. So like there's a 0 at -1, boom. There's a 0 at 2 right there. And then there's one at 3/2, which is, right there.
Oh, I see what you mean.
Okay. Then you look at this. Oh, it's odd. It's odd degree. That means it's down and like this because A is greater than 0. A is 2 in this case. So this is where students have a little struggle. You connect, get something like that. Connecting them. You should at least though be able to get the zeros and the end behavior on your own.
Could you briefly answer number 53, please? The rational zeros theorem. Like I don't understand what that means.
Yeah, I'll run through this one here. You said 53.
Yes, please.
Yeah, so there's this theorem, and they call this it's a P over Q thing, and this is P, and this is Q. So you have to find all the factors of, and it's really absolute values. In this case, it's absolute value -6. So those are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6.
Okay.
And then you do the same thing for Q. All the factors of 12, in this case, absolute value 12. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So the rational zero theorem says that you write all the possibilities here. So you take 1 and you divide it by each of these numbers. Then you take 2 and divide it by each of these numbers. Then you take 3 and divide it by each of these numbers. Then you take 6 and divide it by each of these numbers.
Oh, okay.
Okay. And once you've done all that, that's your list of numbers to try. So I know that wasn't clear, but this is you're producing a list and then you try this list.
Oh, so like 1 over 1, 1 over 2, 1 over 3, 1 over 4.
1 over 4, 1 over 6, 1 over 12, 2 over 1, 2 over 2, 2 over 3, and so on. If they're duplicates, you don't try them again. This is a really hard problem because you don't have any information to go on. If you have 1 0, though, you can reduce it to a quadratic, and that's what you do by doing this. So what I would tell you to do is to graph and find 1 0, and then use synthetic division to reduce to a quadratic, and then use either factoring or quadratic formula.
Alrighty.
The rational zero is like imagine the olden times when you have computers and all that. You can, I can't even imagine that, but you would try these numbers until they worked. You could try for a long time. So we actually need quite a bit more time to actually explain that in more detail. So if that wasn't clear, just say, you know what, it wasn't clear. I'll get you onto it next time. I do have to run. I'll send you the notes and the video here shortly as soon as they upload.
Thank you, Matthew. Enjoy your day. I appreciate that.
Okay. Bye now.
Bye-bye.